Hello, I'm Kamil, and in this video presentation, we are going to discuss about regression models with my colleague Atakan Yontar. A regression is a statistical technique that relates a dependent variable to one or more independent variables. Basically, we have three different regression types. These are linear, as you can see here, multilinear, or nonlinear, as known as polynomial regressions. Um, However, we are going to discuss only linear and polynomial regressions. In regression, you are trying to find a polynomial function which is called a model that can be set relatable regarding to your data as much as possible. To analyze that your model is considered either good or bad, there are some methods used. The outcome of your model is called estimation, where your input data is called training data. This type of learning considered as supervised learning, but however, in supervised learning, we have a training and a test data to test our data. But in this video, this is not our topic. We are going to talk about supervised learning, but not gonna go that deeper. To check the errors of the training data and our model, we have some errors such as R squared, least squares error, mean squared error, and so on. Basically, the error is the difference between our test data and our estimation. And these three or more methods are used to find the better models. In this and upcoming video, we are implementing some of those methods, so let's get started. In this video, our scenario is simple. In 2012, Donald Trump thought climate change is a lie and China is a liar, which is a total lie. In our dataset, we are going to prove that we are right. In our dataset, we have temperatures measured in cities between 1961 and 2016. To examine these datasets, the first step is to divide the data into training and test data. As you can see here, we divide our training and test data by years. After climate class, which is our helper class that helps us to read the file and get values, get temperatures by yearly and daily. And we have standard error overslope function. This function is calculating the error in linear regression model, which is the position on the output of the model and our test data, which is estimation minus test data, or test minus estimation data. In our task, we are responsible for implementing generative models, R-squared error function, and evaluate models on training. So let's get started. In generate models function, we are generating our models using polyfit function that from the PyLab library. This function generates your model the degree that you want regarding to input and output that you gave. Here we are printing an example of it. As you can see, the output in the documentation and our output is much closer in each other. So we are doing things right. To check R-squared error of our model, just calculate the division of sum of the squares error, which is the distance between the line and actual test data, to total sum of the squares, and subtract it from the one. As you can see here, we just calculate the mean to prevent the complexity and readability, provide the readability of our code, and we just subtract it from 1. The main objective is here to implement this function. Actually, let's little quick back. To calculate the best fitting model to our data, we are counting on R-squared error method function. If our model's R-squared error is equal to 0, our model cannot be used in our research. So there are some things wrong, right? On the other hand, if our R-squared error is 1, our model is probably memorizing the data set. Actually, we don't want that, so we cannot use our model either. In this function, as you can see, we prevent the memorizing to raising a custom exception at top of the place. As I'll show you later. In this function, we are looking for our model regarding to R-squared error. In every iteration of our model list, as you can see here, we are doing an estimation using the polyval function. The action that polyval function does is basically calculating your output regarding to your function and input, which is our model and our training data. And we are getting an estimation. After that, we are calculating the R-squared error and R-squared error with our test data and our estimation, which is produced from the training data. To compare that, after the R-squared error is computed, we compare our models regarding to our R-squared errors. After finishing our iterations and loop, we return the properties of the model, which are the model itself, the best fitting output data, which is our estimation, and the model's R-squared error, and if our model's degree is equal to 1, we return the standard error of that individual model. In plot best function, we just basically plot the dataset and our regression model to a graph. If our model is linear, which I mentioned about that, degree is equal to 1, the squared error is also plotted. And this is the basic exception that we are showing right here. If our to the case that where our model is memorizing our data. Don't forget, please don't forget that we don't want to memorize our data. In the main class, I wrote some example, which is comparing the data, which our test data is 13th January of every year in New York's temperature. After we pulling the data, we just add them to our test data array. After we get our test data as day 13, I named that, we generate our model, as you can see, degree of 1. The reason that degree of 1, I just want to show you the linear regression and standard error plotting. As you can see here, this is not the best fitting line. This is the best fitting line, but because of its degree is equal to 1, we cannot, we couldn't have the best polynomial line, best polynomial regression. Let's increase the degree of 1. Let's see, increase it, what about 13 again? As you can see here, our line is shaped and it's not linear, but it's more shapy. But the errors and the errors between the points, test and estimation, are less than the before, less than the graph that we had before, which has the degree of 1. Thanks for watching my video. I'm a little bit exceed my time, but please forgive me. Thanks for the video.